push record and minimize, and then you won't see that. You don't need that page. So now when I take a screenshot of it, I get just this. Okay? So I need a polynomial of degree 2 that has the numbers -1 and 3 as zeros. Let's stop right there and solve that. In other words, give me a polynomial, a second degree polynomial, which is a quadratic, that has the zeros -1 and 3. Therefore, what are its two factors?
Oh, just
remember, the factor is always x minus the zeros.
So it would be 1
X plus 1. That's one factor. What's the other factor?
X minus 3.
Okay. Multiply those two together. What do you get?
X squared minus 3x plus x, so minus 2x minus 3.
Okay. So there's the polynomial that satisfies the first part of that question. There's a second degree polynomial that has those two numbers as its zeros. Now, it wants a y-intercept of -2. We've got a y-intercept of -3. What do I need to multiply my polynomial by in order to make this number turn into a -2?
Is it?
I'm going to multiply it by some a. Okay. And when I'm done multiplying it by a, I'm going to have a polynomial, and this last number is going to be -2 instead of -3. So what does a have to be?
I know it has to be a fraction of some sort.
Yeah, 2/3.
Okay, 2/3.
Notice that if I multiply that whole thing by 2/3, it turns that constant into -2. And in fact, this is the answer. 2/3 x squared minus 4/3 x minus 2. In other words, when I multiply that times that, it becomes -2. And this polynomial that I came up with, I can still say it's equal to 0, because all I did was, it was equal to 0 originally, because all I did was multiply both sides by 2/3. Well, 2/3 times 0 is still 0. So I still get the answer they're looking for is equal to 0. In other words, the zeros of that polynomial are still -1 and 3. You don't change the zeros of a polynomial just necessarily by multiplying it by a constant. The zeros stay the same. All right, let's look at 68. Hold on. Erase all ink. Okay. Construct a polynomial of degree 3 that has the numbers -3, -1, and 2 as its zeros. So let's stop. First of all, give me that.
X plus 3, x plus 1, and x minus 2.
And now that's equal to 0. It's also equal to f of x. Okay? Now, they're saying that f of -2 has to be equal to -12. Well, 1 second.
Okay.
Hello? Hey, Glenn. Glenn, I'm in the middle of a tutoring session. Can I call you back? It'll be around 8:30. All right, bye-bye. sorry about that.
No, it's fine.
Let's see if I have to multiply these together. In other words, I can take this function and multiply it by any a without changing the zeros. You get that part?
Yeah.
Okay. So let's see what f of minus 2 is equal to. They want it to be equal to minus 12. Well, what do we get when we plug in minus 2 here? Get 1 times what?
Oh, times -1
Okay.
times -4.
Okay. So we get, with our function, we get f of minus 2 equals positive 4. Well, they want f of minus 2 to be minus 12. So what does my a need to be?
Positive 3. Wait.
Close.
Or
Negative 3.
-3.
Negative 3. In other words, I need to precede that polynomial with a negative 3 like that. Now my f of minus 2 is still going to be this number, but times negative 3, which is equal to minus 12. So I don't actually need to multiply this whole thing out like they did in their example. All I have to do is figure out what f of minus 2 is with my basic polynomial. And if that comes out to be 4, which it did, then I've got to multiply my polynomial by minus 3. So this would be the answer. And I imagine you could give it just like this. I can't imagine that they actually multiply those out. No need to. And maybe they do, just because of the way the question was structured. In other words, the question is construct a polynomial. Well, that's not really a polynomial. That's a polynomial that's factored. Okay?
Mm-hmm.
So undoubtedly, if I were to look at the answers here, I'm betting that, man, hold on. There we go. I'm betting that they have to multiply all that out. Let's see. What number is that? 68? Let's see what they got for an answer at the bottom. Yeah, they did. They multiplied it all out. But notice, if you take my polynomial, multiply it by minus 3, that's the first term you're going to get. And if I do f of minus 2 here, it's going to be equal to minus 12. Okay? But you do need the whole polynomial. In other words, I can't leave it in factored form, which is the way I had left it. Normally, factored form is not bad at all. I'd rather have something in factored form than not. But when they specifically request you to construct a polynomial, then they want it in this form that you're looking at up here. All right, let's do 69. Hold on a second. Let me blow it up a little bit and then take a snapshot of it. All right. So first of all, let's do the first half. In other words, a third degree polynomial that has those zeros. Let's worry about your second condition later.
Okay. So it'd be x plus 5, x minus 2, and x minus 4.
Now here, I can say that that's 0, and that's not the f of x they're looking for because it doesn't have the proper intercept. So, in order to know what the intercept is, I could either multiply these three things out, okay? Or, if you happen to know this, it's these three numbers times one another that's going to give you the y-intercept, right? In other words, when I multiply these three out and I get a third degree polynomial, it's got one constant, the last number. That's my y-intercept, right?
Yeah.
So what would the last number be if I multiplied these three things out without actually doing it? You know what? That's not going to help us now that I think about it. Well, only because they want that polynomial. In other words, that would be a shortcut. I can tell that that constant's going to be 40 because 5 times negative 2 is negative 10. Negative 10 times negative 4 is 40. So I can tell that my y-intercept would be 40 with this polynomial. So what am I going to have to multiply it by? What's the...
fraction of 1/4?
1/10.
1/10. Okay, that makes more sense.
Right, because it was 40 times 1/10, it'll become 4.
Okay.
Okay. So I got the polynomial pretty easily, but that's not the answer. We just looked and we know that they want a cubic. So let's multiply this out. Let's make sure you know how to do that. Multiply x plus 5 times x minus 2. Ignore the 1/10 for a moment, just because you don't need it yet. Let's multiply these three things together.
Okay. So it'd be x squared minus 2x plus 5x, so plus 3x minus 10.
And then I'm going to multiply that by x minus 4. And I usually put it in front just because it's a little more easy to understand. Multiply those two.
X cubed plus 3x squared minus 10x minus 4x squared minus 12x plus 40. So it would be x cubed minus x squared minus 22x plus 40.
Did you notice how I did that where I lined everything up?
Yeah.
Instead of just writing it as one big long row and then trying to figure out how many x cubes you have or x squared. Yeah. If you line it up like this, then it's just real easy to add everything. So this polynomial has a y-intercept of 40. So if I multiply, in other words, I know that this is equal to 0, okay, because of that. In other words, those were the zeros. So I know if I multiply this thing out, it's equal to 0. So now I can multiply each side of this equation by 1/10. 1/10 times 0 is still 0. So my answer is x cubed over 10 minus x squared over 10 minus 22/10 times x plus 4. And that plus 4 is what gives us that y-intercept.
Okay.
Okay. All right. Good. Those, I'm glad to be done with those. Those are kind of hard. These tend to be a little easier. Here, what do we got? We got 10 minutes. Okay. When you see a problem like number 70, know that it is a factoring problem. I'm looking at a quadratic. And anytime you see a quadratic, you should be thinking factoring.
Okay.
And in the denominator is difference of perfect squares. It's also a quadratic, so you should also think about factoring that. First of all, what's the denominator factor to? Difference of perfect squares factors how?
Oh, x plus 3, x minus 3.
Okay. Now, I would bet dollars to donuts that one of the factors in the numerator is one of these. Okay? You with me? It's just the way these problems come out. They're not going to give you something that doesn't give you something to cancel. Now, if I go to factor the numerator, I know that much for sure. Signs have to be opposite. Well, that means the 5 is going to have to go there. The 3 is going to have to go there. And I've got to produce a middle term of plus x. The only way I can do that is plus 3 and minus 5. And you see why that produces a middle term of plus x.
Yeah.
Okay. Now, just like I thought, we've got one of the factors in common between top and bottom. So we can cross it out. What we got left is the remaining thing on top and the remaining thing on the bottom.
Okay.
Okay? And that's the way these problems are always going to go. 71 is going to go like that. 72 is going to go like that. 73 is probably going to go like that. So, let's see. Yeah, we got time to do 71. Wow. It's the greatest common factor of the numerator.
Looks like 2.
2x.
2x.
And the x is important because if I don't factor the x out, I've got a cubic left. And I don't want a cubic. Cubics are hard. Quadratics I can do. So far, so good?
Yeah.
The bottom. No greatest common factor. But I can probably factor it. It's not easy. I tell you what, whenever you're factoring a quadratic that's got a negative coefficient in front of the x squared term, it really is helpful if you can make that positive for factoring it. Makes it so much easier to factor. Well, what if I divide the bottom by minus 1 as long as I divide the top by minus 1? Well, that puts a negative in front of that minus 2x. And the bottom now becomes 24x squared minus 2x minus 5. And now at least that probably factors a little bit easier. These are always factoring problems. That's a particularly hard denominator to factor because 24 has so many factors. I know 12 and 12 isn't going to work because 5 only has 2 factors, 5 and 1. Okay, so I'm going to try maybe 6x and 4x. That won't work either. In other words, even if I multiply the 4 by 5 and the 6 by 1, I'm going to have 14. So let's go back and try a 12 and a 2. 12x and 2x. Now notice I'm getting somewhere. That's 10. That's 12. My middle term is minus 2x. So all I need is a minus sign there and a plus sign there. That's the way that bottom factors. Okay?
Mm-hmm.
Now, the top. That thing probably factors also. Still got the minus 2x. And let's see, if I multiplied that by x minus 1, that would not give me that top term. Let me think for a minute how I'm going to produce a 4x. Now, if I do 6, hold on a minute, let's see, I need another parentheses here. Not even sure this thing factors, I'm just assuming that it does. Here, let me erase it so I got room to write. All right. Now, I'm tempted to say one of the factors is 2x minus 1. In fact, let's pretend it is. That would make the other factor 6x plus 5. Now, does that give me a middle term? It does. Notice that making that guess made it far easier to factor this quadratic. In other words, as soon as I guessed that one of the factors was 2x minus 1, well then the other one's got to be 6x here and it's got to be plus 5. And then does that produce the middle term of plus 4x? Yes, it does. And now we can go to town canceling. That cancels with that. And what we're left with is minus 12x minus 10 all divided by 12x plus 5. And that's your answer. That actually does not simplify.
Okay.
I could factor a 2 out of the top, but that doesn't really help. I just had a 2 factored out and it came back in. So, like I said, you don't always want to factor. But when it comes time to simplifying, you always want to simplify. In other words, if this was a 6 down there, then I can simplify that. I can divide top and bottom by 2. But as long as that's a 5, there's nothing I can do. Can't pull out a greatest common factor and cancel it, so that's my answer. That's what the back of the book or the bottom of the test would say, is this answer here. All right, let's stop there at 71. I'll make a note, and I will talk to you next time.
Okay, sounds good.
All right, bye-bye. Have a good one.
Bye.